Hello Mr. Satoff and anyone else who may be watching. This video will explain the purpose and basics of covalent bonding and ionic bonding in chemistry. Before we begin, let's look at the periodic table and how it's going to play into our bonding lesson. This periodic table was originally arranged by Dmitri Mendeleev in 1869. There are many special ways about how the table is arranged, such as the atomic number, average atomic mass, and of course, the elemental symbol and name. What I'm going to be focusing on when regarding the periodic table will be the meaning of each of the rows. The vertical rows, starting with 1, are the number of electrons an element has in its outermost ring, also known as its valence electrons. The final vertical row on the periodic table contains the noble gases. These atoms are the most stable because they have a full outermost ring, but we'll get to that in a little bit. These horizontal rows show how many energy rings each atom contains. Before I start my examples, I would like to explain that I will be using Niels Bohr's atomic models. This is not the most correct atomic structure, but it is a lot easier when looking at it visually when discussing these bonds. Atoms use bonds as a way to get a full set of valence electrons, which allows them to be the most stable. There are two types of bonding, ionic and covalent bonding. Let's start with learning about ionic. Neon and helium both have a full set of valence electrons due to the fact that they are noble gases. This means that they will not be doing any bonding. Let's say we have two atoms, one lithium and one chlorine. As you can see, lithium has 1 valence electron and chlorine has 7. When trying to get a full outer shell, lithium is going to try to get rid of that valence electron and chlorine is going to want to gain one. So what will happen is the lithium atom will give up one of its electrons so chlorine will take it. Now both atoms are most stable that it can be. When working with losing and gaining electrons, the atoms are gaining and losing a negative charge. So in this example, lithium is losing an electron, so it will now be positive, because there are more protons than electrons. Chlorine is now gaining electrons, so it will now have a negative charge, because it has more electrons than protons. Now on to covalent bonds. Atoms are trying to still get that full outermost shell, but sometimes rather than gaining or losing electrons, they just share them. Chlorine atoms, for example, have this option. It works out pretty well. Their 7 electrons on their valence shell means that they only have to gain 1 electron. So one option for them is to share their electrons. So each will gain an electron in their outer shell. This is called a single bond because they are only sharing 1 electron. Now, if 2 oxygen atoms share electrons, they would both need 2, because they have 6 of their 8 valence electrons in their outer ring. So in this situation, they would share 2 electrons, also known as creating a double bond. Seeing a connection? This also applies to nitrogen in the same way, except these atoms have 5 of the 8 that they require. So in this case, it is a triple bond because they are sharing 3 valence electrons. The other important thing to know about covalent bonds is as the number of bonds go up, the strength of the bond goes up, so the triple will be the strongest. But the single bond is going to be the longest in length, and then it goes down from there. Thank you for taking the time to watch my video on the basics of covalent bonds and ionic bonds in chemistry. I hope you learned something today.